So we look at the question now, when is the depth equal to whatever value? Let's say, when is the depth 200? Now I chose 200 because it's between the 175 that we get here and the 400 that we have here. So we know it's going to occur. So if we want to go to 200, if this is 175, we could estimate on our graph it's probably going to be maybe around here. And that looks like maybe halfway to 150, maybe 75. Of course, the graph might not be all that accurate. So that was just a very cursory estimate, but we need to be able to do those. So we're pretty sure the depth is going to be 200 at some time, though. So this occurs when y of t equals 200. Of course, y of t is this function. So we write 0.01 t squared minus 3t plus 400 equals 200. Now, please, don't try to solve this like you would a linear equation by isolating t, getting all the t's on one side and dividing out by coefficients. It won't work. This is a quadratic function. It's got both a t and a t squared, and any attempt to solve it in that way, not only will it get no credit, but it's just going to be confusing and disorienting for you. Okay, so this is a quadratic equation. And the quadratic equation, of course, has to be in the form at squared plus bt plus c equals 0. And this doesn't have equals 0 here, does it? So we have to subtract the 200 from both sides to put it in this form. And now we can apply the quadratic formula. Now ordinarily we would evaluate the discriminant, because if the discriminant is negative, we're not going to have any real solutions. But from the graph and from our previous work, we certainly expect that we will have solutions. Matter of fact, we'll have two of them. If 200 is here, we'll have a solution corresponds to here and here, won't we? Now, the solution we get over here doesn't correspond to the real world phenomenon, so we're going to ignore that solution because we've already excluded this part of the parabola from our domain for that reason. But let's see what we got. Okay, so t equals, now I'm not going to write down the quadratic formula, well I've written it down here, and I'm not going to go through the details of that because I think everybody is okay with how that works. We get negative b, which is negative 3 plus or minus the square root of b squared minus 4 times a times c over 2 times a. Well, this is going to then equal 3 over 0.02 plus or minus. Now, just coincidentally, I just picked that 200 out of a hat. I didn't intend that this would come out so nicely. But what you have here comes out as 8. This is 9. 9 minus 8 is 1, and the square root of 1 is 1. So the square root is going to be 1. You can verify that. Okay, so we get this. And 3 over 0.02 is 150. 1 over 0.02 is 50. And then we get 200 or 100. 150 plus 50 is 200. 150 minus 50 is 100. Okay? Now, as we said, the 200 would occur over here. So that's not part of the solution to the real world problem. It's a perfectly good solution to the quadratic equation, but it's in the part of the domain that we've excluded. Our domain, in this case, would only run, say, from 15 to 150, or from wherever we started to 150. It would not go into the part of the parabola where the depth would be increasing again. Okay, so we exclude 200, and we then conclude that depth equals 200. We exclude t equals 200 since we have 200 for t and 200 for the depth. Depth equals 200. when t equals 100. So, you know, I kind of estimated maybe 75 here. Well, you know, small graph, not a great graph. And it's actually over a little closer to 150 where we hit the 200 mark. Okay, so if we've got 200, it occurs here at the point that projects down to 100. Okay, anyhow, that's how we solve it. That's how we use the quadratic formula.